So 4.2, you learned SSS and SAS, right? So SSS was the triangle congruence where you know all three sides. SAS was the triangle congruence where you have the two sides and the what kind of angle? Do you remember what that word was? The included angle, right? It was the angle that falls between the two sides. Today, we're going to flip that around and do ASA instead of SAS. But it's the same thing, just with angles, two angles, and the included side. So it should look very familiar. This is why I tell people sometimes to put S's and A's next to the things on their triangles, just because a lot of times ASA and SAS get flip-flopped because people are just rushing through. So take your time, make sure it's ASA and not SAS or vice versa, and you should be good. So first one we're going to talk about is ASA, which is angle, side, angle. Okay, so like I said, just like SAS, now on this one, that S has to be the included side, which maybe looks a little different since we were talking about an included angle before, but they really are the same idea. So if this is triangle A, B, C, and this is triangle L, and then M and N, and I give you as markings that angle A is congruent to angle L, and AC is congruent to LM, and angle C is congruent to angle M. Okay, you have the two angles, and where those two angles rays meet is the side that has to be marked for you, okay? So it has to be the two angles with the side in between. Notice you're going to learn today AAS as well, which is a non-included side. And people always ask, how do you know where to start on these? And the rule is, if you pick an angle or a side and you move one direction and you hit another side and another angle with no markings, you're going the wrong way, okay? You want to go, so like if I'm here and I go this way, well, here's a side that's not marked, here's an angle that's not marked. If you hit two that aren't marked, wrong way. Turn around, go the other way, okay? So instead, I start here at angle A, and then next to it is a side, next to that is an angle, so angle, side, angle, okay? Can you tell me the congruent statement here? Triangle what is congruent to triangle what?
Triangle ABC is congruent to triangle LSN.
ABC, so from a single arc to no arc to a double arc, has to go from a single arc, L, to no arc, N, to a double arc, M. Okay? So we would say triangle ABC is congruent to triangle LNM by angle, side, angle. Okay? Okay, so I'm going to give you three triangles and see if you can tell me some triangle congruence. Which triangles are congruent by ASA? And here are your triangles. What is watt?
It's a type of electricity measure.
Isn't that two T's? Yeah. Well, so it's not actually spelling it. But yes, they are all close. Okay, so let's say this is your setup. I'll give you a sec to finish drawing it. When you look at the first triangle, do you see ASA?
Yes.
Yes. You have the angle, the side, the angle, right? That's ASA. When you look at the second triangle, do you see ASA? Yes. You have the angle, the side, the angle. When you look at the third triangle, do you see ASA?
No.
No, because if it were going to be ASA, you would need angle this side and the angle, right? So this one is not ASA. So we know it's the first two, but now you're not really done with the problem yet because you have to name the triangles that are congruent and you have to name them in the right order, right? So triangle what? If we're dealing with SUV, how about? Okay, triangle SUV. And the way I always say it is look at your angles. So angle S has nothing there. So you want to match it up with nothing there on the other one. Angle U has one arc, so match it up with one arc. Angle V has two arcs, so match it up with two arcs. Okay, so SUV is congruent to what?
NEO.
NEO. Okay, by angle, side, angle. So that is your congruence statement. Which two triangles are congruent by which postulate? Okay? All right, let's say we're going to do a proof here. Example 2. You are given that angle CAB is congruent, not to triangle, to angle DAE. Segment BA is congruent to segment EA. And angle B and angle E are right angles. Okay, we have to prove that triangle ABC is congruent to triangle AED. And here is your picture. That's going to be too big. Sorry. If you can keep going on that. I need to make more space for myself over here. We're going to do this. That's not my best work. The trick for drawing these is you need a right angle down here. So try to make that look like a right angle if you can. This is C, this is B, this is A, E, and D. Yeah.
I know there's no food, but I have a coffee.
You may have food.
Oh.
I don't have a food rule. So yes, you may have a cough drop. All right, so if this is our setup, you always want to start by marking what you know. So look at the given information. It says, this one's super short. It says that CAB is congruent to DAE. So they really did like the whole proof for you. The point of the proof is to show you one little thing. So CAB and DAE are congruent, okay? And then it says BA is congruent to AE, and it says angle B and angle E are right angles, okay? So step 1 is what?
Given.
The given. So you may just take all this, drop it in here, call it given. Okay, so most people at this point are like, oh, ASA. But technically you can't say ASA yet because you have to say something else first. We said in order to know triangles are congruent, you have to know angle, side, and angle are congruent. We don't quite know that yet.
We haven't said that angle B is congruent to angle B yet.
Right. So we know they're both right angles, right? But we haven't said they're congruent. So we're going to say angle B is congruent to angle E. And if you think back, gosh, what was that lesson? I don't even remember. But there was a theorem that said all right angles are congruent, right? So that's all you have to say here. All right angles are congruent. Okay, so now we know that B is congruent to E, so we can say what?
That the triangles are congruent by the ASA.
Right, so your last step on the left side is always going to be what they asked you to prove. So triangle ABC, I'll just write it in, but you may do an arrow there if you want. Triangle ABC is congruent to triangle AED. By, God bless you, angle, side, angle. Okay? Questions on that? So if they tell you you have right angles, you have to say one step further and say those right angles are congruent. Make sense? All right. Then we're going to do the second one for today. So AAS is angle, angle, side. And the beauty in this one is even if it is angle, angle, side, you could actually get to a point where it's angle, side, angle and just use angle, side, angle all the time. But you have to prove it to get there, which means you're doing more steps, but you're welcome to if you would rather do it that way. Angle, angle, side postulate says you have two triangles that have two angles marked congruent and then a non-included side. So it can't be the side in between the two angles like we did before. So if I have this set up, okay, if this is A, T, V, and P, G, M, if I give you angle A congruent to angle G and angle V congruent to angle P, what's the included side right now?
AV and PG.
Right, AV and PG are included. Now, here's the thing with AAS. I could give you two different AASs right now so that these triangles are not congruent, right? If I were to mark AT congruent to MP, that is not AAS. Do you see why?
Yeah.
Because you're going single arc to double arc to side versus double arc to single arc to side. Those are different triangles, okay? So just be careful with AAS with how your sides are marked. If I mark AT, it would have to correspond to the one that's touching the single arc over here, right? Because this is single arc on the left, so single arc on the right is touching MG. So that would be AAS. So make sure you're just making them be the corresponding sides and corresponding angles. So we would say here triangle ATV is congruent to which triangle? Right, so if I went from a single arc to no arc to a double arc, then I have to go single arc with G, no arc with M, double arc with P. So we would say those two triangles are congruent by angle, angle, side. Okay. The other option is you could have had these two congruent, and then it's still angle, angle, side, just the other non-included side. And here's your third option. We learned the third angles theorem, right? So technically right now in this problem, we know that angle T is congruent to angle M, right? That's third angles theorem. So if we know that, then we have angle side angle here and angle side angle there. So AAS can be ASA every single time as long as you use the third angles theorem. Okay? So just one more thing for you to look out for if you prefer to look at it that way. Okay, we're going to do one proof and then one last question, and we're done. All right, so given that M is congruent to K, WM is parallel to RK, we're going to prove triangle WMR congruent to triangle RKW, and here is your picture. Okay, I told you to write this on your paper before, but best thing you can do for yourself is mark up what you know, because when you mark what you know, it helps lead you to the next things that you want to know. So first thing we're going to say with our markups here is angle M is congruent to angle K. So we're going to mark those congruent, okay? We also know that we have lines that are parallel, and I feel like that's an easy one to skip, because it doesn't affect like ASA or SAS with our markings. However, when you mark them parallel, it should trigger you to look for what? Alternate interior angles. When you have parallel lines, WM parallel to RK, chances are you're going to see some alternate interiors somewhere, okay? So that takes care of this one. And then we're going to walk through a proof. What's our first step going to be? The given. So we're going to take that information, put it here, call it given. Then consider your given. Our given said lines were parallel, and here's where you have to be a little bit careful. There are not two sets of alternate interior angles here. There's only one set. Do you know why there's only one set? Yeah.
Because there's the, wait, I think I saw this. Oh, RM and RM cuts off the whole angle from the line KR, and then also WK cuts off the other half of the angle that's on line WF.
Okay, so there's one pair of parallel lines, right? It looks like there's two. See you, Cindy. But they only gave us one pair of parallel lines. So you can't say that these angles here are alternate interiors because we don't know that MR is parallel to WK, all right? But we do know that these lines are parallel, which means these are alternate interiors, right? So we can say angle MWR is congruent to angle KRW. The reason being we have alternate interior angles. Okay, so that's AIA. Do you see anything else in this picture that we know is congruent? It's one of the things I told you to always look for because it shows up a lot. WR, right? If you're looking at the top triangle, WR is this bottom side. If you're looking at the bottom triangle, it's that top side, but it's exactly the same side. So we would say WR is congruent to WR by what? That is the reflexive property. Okay, so since we did all our markings, what do you see?
Angle, side.
Right, you are going from angle to side, and angle to side. So we can say that triangle WMR is congruent to triangle RKW by angle, side. So as soon as you see SSS, SAS, ASA, or AAS, you know you can say triangles are congruent by that thing. Okay? Yeah.
Also use the third angle theorem, right?
You could have, instead of doing step 4 as the triangles congruent, you could have said that these two angles are congruent by the third angles theorem. And then once you know that, you could say ASA for your final step. So if you're going to do it ASA way, it just adds a step to your proof. Okay? Any questions on that? Okay, last question. Isn't it right now? Oh, okay. So this says, is triangle BIF congruent to triangle UTO? And here's our picture. So this is BIFO. T and U. And here's what we know. We know that angle B is congruent to angle U. We know that angle I is congruent to angle T. And we know that BF is congruent to OT. I didn't draw that very well. Okay, so the question is, are those two triangles congruent? Who thinks yes, those are congruent? Who thinks no, those are not congruent? You got 3 opinions, 4 opinions? You're all still drawing. I'm rushing. Is that what it is? A little bit. Should we try again? Oh, we got more. You guys are popular today. Thank you. Oh, it's for you. It's probably a note saying, just kidding, 9:45. Okay. Who thinks yes, these are congruent? Who thinks no, these are not congruent? Got a couple more opinions. Good job. The answer is no, right? And this is what I told you about earlier. If I go double arc to single arc to side, right, that is AAS. But then on this one, I went single arc, double arc to side. That's a different order. So it's not that this is not congruent. It's just that we don't know, okay? So are they congruent? We're not sure. There's not really enough information. So we'll just say not enough info. Not wanting to write right now. Oh, my goodness. Let's try that again. Okay, not enough info. It's not the same non-included side. Okay, questions on that? That's it.